Okay, we have to write down an estimate for square root of 78. Okay, now how we will write the estimate of square root of 78? Look, if I will write the number square root of 78, what is the perfect square before 78? Is 64. Which one is after this one is 81. I always recommend you to go to the closer one. That is best. So this one is the closer one, so it means I will use this one. 78 square root. Now I can write it 81 minus 3. Now what is square root of 81 if you take? Square root of 81 is 9 minus 3 over double of 9 is 18. So 9 minus 3 over 18 if I will take 9 minus 3 over 18. It will be 8.8333. So you can write 8.83. So if you will take directly to check your answer, 78 square root will be 8.833. So that is pretty close because we are doing estimation. We are not writing 100% accurate answer. Now for the cube root it's pretty slightly different you can say. For example, I have to take the cube root of this one. Like let's suppose I want to take the cube root of 30. So what should I do? I should write 30. Now which cube number is before 30? Obviously it's 3 cube because look, if you take 1 cube it is 1, 2 cube is 8, 3 cube is 27. So the cube number before 30 is 27. And the cube number after this, if you take 4 cube, is 64. So it's 64 after this because it's greater than this one and less than this one. That is okay. Now what you have to do, take the cube root of all of these. Take cube root of this, cube root of this, cube root of this. Okay. Now what it will be? It will be 30 cube root. Now this is 4. Now what you have to do is we have to go for the approximation now, obviously. So which one is closer? If we look at this one now, it's between 3 and 4. Its answer will be between 3 and 4. So you can take halfway between 3 and 4. That you can say, okay, approximately it will be 3.5. And if you will use your calculator, cube root of 30, it will be around 3.1. So it's acceptable because we are estimating. We are not using the exact value. So in that way, you can use that one. Okay. Yes, Afif.
Sir, I solved this question number 23 the exact way the previous questions have been solved. Is that a method acceptable as well in this case?
No, actually, the thing is, you can say, yes, let me try with that one. Frankly speaking, I never tried that, but let me try that one too. It's 30
You
cube root.
also get 3.5.
Yeah, you can do it in the pretty same way. You can write it like this one. You can write it, okay, 30. Now what it will be? It will be 27 plus 27 plus 3 cube root. And then you can do, what is the cube root of 27? It is 3 plus 3 over the double of that, or in case of cube root, we do triple. I'm not pretty sure if we do triple. Let me do triple. But you can do that also. It will be acceptable. Okay. Now let's do the estimation of this one. 594, if you will root to one significant figure, 600. Okay, to one significant figure, 4 over to one significant figure will be 0.4. And then calculate that one. It will be 600 multiply with 4 divided by 0.4. So will give me 6,000. Okay. Now for this one, when you have to do approximation, so it is because right now it's involving a division sign, so you can do that. It's round to one significant figure. It will be 50 over rounding to one significant 0.5, and then square root is involved. So if already division and square root is involved, then you can use the same way. 50 over 0.5. So that will be 10. Sorry, square root answer is going to be 10. So if check it directly, if you will solve it, 50.77 over 0.513. So 9.94. So approximately you work really well. It's 10 because it's estimation. It's not an exact answer. Now 803 into 2.97. Round to one significant figure 800 time round to one significant figure is 3. Round to one significant figure is 0.6. So what it will be? 800 times 3 over 0.6, 4,000. So if directly you calculate, you will be near to that one. Rounding, of course, will give you approximately that one. Okay. Now this estimation is clear. Please let me know, everyone. Are you clear about this
Sir, could
estimation?
you just scroll back to the previous page so that I want to take a screenshot of the entire page.
For this one?
Is it possible to like zoom out?
Yeah, it's quite possible. How much zoom you want me to do?
I just want to be able to view the whole page so that I can
The
take
whole
a
page.
capture a screenshot
Okay,
of
no
this.
problem. I will go even. Is it now? Okay.
Yeah, it's visible now. Take a screenshot, sir.
Yeah, sure. Take.
Okay, sir. Thank you. I took it.
Yeah. Okay. Now moving to sorry. Just for a while. Okay, so our previous lesson, if you remember, was about convergence. Yes, our previous lesson was about convergence from one unit to another
Yes.
unit. Yes. Did I share the sheet with you? Frankly speaking, I forget. Did I share
Yes, sir.
any? Did I share?
Yes.
Okay, let me hold on for a second. I will, we have to write these recurring decimal as fraction. So what I need to do is to write these recurring decimal as fraction. I will say let x is equal to 0.48, which if these two dots, what does these two dots mean? These two dots mean I can write them like 0.4848 and so on. This is my equation number one. Yes. Now how many digits are repeating here? Simon, can you let me know how many digits are repeating here? Because the
Two.
dot is on so
Sir,
two digits are
two
repeating.
digits.
So what we do for the two digits, we multiply both sides with 100. Yes. So I will say multiplying
Yes, sir.
by 100. Yes. Mean I will multiply this with 100. It will become 100x. I will multiply this with 100. Okay. Let's multiply with 100. 0.4848 multiply with 100. So will be 48.48. Okay. Now, but I told you should write the same number of decimal places, 4 decimal places. So write another 48 because as many you want, you can write. So this is second equation. Now what is next step? What do we do in the next step? We do by second equation minus first equation. Okay, from second minus first. So left side from the left side, right side from the right side. So 100 minus x is 99. And this minus this one will give you just 48. So what x will be? 48 over 99. That was okay. Now this one is change 6200 centimeter square into meter square. Okay, you are converting a square unit into another square unit. What is the rule? The rule says that if you have to convert centimeter into meter, what do? We divide by 100. Yes, for conversion from centimeter to meter, we divide by 100. So if it is centimeter square to meter square, then double the number of zeros because so apply this rule on this one. 6200 divided with 10,000 will make it meter square, because it was before centimeter square. When you divide it with 10,000, so it gets converted into meter square. Okay, now let's do it. 6,200 divided with 10,000. So it will be 0.62 meter square. That was okay. In the next one, write the recurring decimal 0.2 as a fraction. Now this is a recurring decimal and you want to write it as a fraction. So what we have to do is, I will say let the given one is equal to x is 0.2 and there is a dot on that. Mean this 2 will repeat. You can write it 0.222 so on. Say this is equation number 1. Okay. Now how many digits are repeating? Just one digit is repeating. So if just one digit repeats, what do? We multiply both sides with 10. So I will multiply by 10. Okay. When I will multiply 10, I will multiply x with 10 will become 10x, because only now one digit. In the previous one was two digits repeating. So I multiplied with 100. Now in this one, just one digit is repeating. So I multiplied with 10. Now this one, when you will multiply 0.222 with 10, so what will happen? Use your calculator. It will be 2.22. But look, here we write after decimal 3 digits. So make sure you write the same number of digits. So further calculation will be quite easy. Now next, what step we do? We do equation number 2 minus equation number 1. So it will become 10x minus x will be 9x. And this minus this, what it will be? It will be 2.222 minus 0.22. We'll get 2. So what x will be? 2 over 9, because shifting 9 on the other side will divide it. It will be 2 over 9. Okay. Now, I think